Yes. So next जो हमें discuss करना है that this is something related to security, access control, right? वैसे practical में ज़्यादा समझ में आएगा, but we have to have some conceptual things also. Access control. अब जब हम S3 में कोई भी डाटा अपलोड करते हैं, by default it is secure. See, we are uploading the data on the cloud. Security is very important because once you have it there on the cloud, so it is obviously going to be visible and available to everybody as such. But here, by default, your data, your bucket is all secure because nobody has the permission except you. You are the owner. You are the owner of your account. You are the owner of this bucket. So you as such, you have got full permissions. Owner means you have the full permissions. But except for you, nobody else is having any kind of permission. Right? Permission needs to be granted. Right? So जब हम permission देते हैं, so for the first time anyway, you are going to provide the permission. So two types are there. One is the coarse grain access control, meaning एक मोटे तौर पे जो हम permission देते हैं, right? Access levels are very limited here. We have three access levels: read access, write, and full control. Right? You can provide the permission at the object or at the bucket level. Read means that if suppose you give somebody the read permission, so that fellow can read, right? But cannot modify the things. Write means that fellow can read and write both. Can read the data, can read the text file, and can modify also. But full control means full control. That is read plus write. And if suppose this user wants to give access to somebody else, wants to delegate the permission to somebody else, that is again possible. So full control is just like having the full ownership, right? So in coarse grain access control, we are using ACL, access control list, ACL, right? Which you can define at object level also and bucket level. Object level means if suppose you want to give permission to a particular object, you can do that. But if you want to assign the permission at bucket level, means that this is a bucket. You give permission here at the bucket level, so all the objects contained inside will have the full permission, right? Another level is fine grain access control, right? Fine grain means you are going to control or you want to specify nitty-gritty access levels, right? And for that, you are using the policies. Just like we have discussed about the IAM policy, similarly, we have here the bucket policy also. So actually, two things are there. If you create a bucket, right, and you want to assign permission to others, you can use bucket policies, right? And we have got the users, what we call them as IAM users, right? By default, IAM users, again, they don't have any kind of permission. In this case, if IAM user needs to access this bucket, right? So it has to be assigned with permission, right? Using IAM policies. So we have the policies at two levels. One is the IAM user level, IAM policies, and bucket level, bucket policies, right? Only when you have the permission at both the levels, only then this particular user can access the content, the objects there, right? That's the meaning. So here actually nitty-gritty access level controls can be defined, just like I showed you last time in the policies. EC2 policy, for example, you are having hundreds of access levels, right? Each and every activity, right? Only when it is permitted, then only you are allowed to do it, otherwise not. In the same way, here we have got the bucket policies. So when you as a owner, you create a bucket, right? So you can define the policies that who can access this bucket, from where he can access the bucket, meaning where means from which CIDR block, and during what time of the day that fellow can. If suppose we say that the contents are available only during the office hours, 9 to 5 p.m. kind of thing. So you can control up to that extent using policies, right? For that we're going to see some examples. Next is static website hosting. Now you can use this bucket to host the website, right? This is possible. Reason is that every piece of data what you upload there is understood as an object, and objects have URLs. So it becomes straightforward to convert a bucket into a website hosting bucket kind of thing, right? But website is going to be static. As such, websites are of two types, static and dynamic, right? In dynamic website, what is so specific? That server-side processing is there. And contents are going to be available, visible to you on the website dynamically as per the user response. In dynamic website, you as a user, you can interact with the website, right? As per your interaction, right? Processing is going to take place at the back end, and the next output is going to be displayed. That's a dynamic nature, it's not fixed. On a static website, you cannot interact. So here actually in S3, we can have only static website, not dynamic, because server-side processing is not possible, right? We have the languages like PHP, ASP, .NET, or JSP kind of thing. So processing is not possible. As I told you that this is object-based storage. So only static websites we can use there for hosting purposes. And once you have the website hosted, so it will have the website endpoint or website URL. And this is going to look somewhat like this, right? Bucket name is always going to be there, right? S3 website, then name of the region, AmazonAWS.com, right? So this is going to make the website endpoint. Yes, it's a different thing that if you want to change, this is not going to be that user friendly. So if you want to change this URL with your own custom domain name, you can do it, right? That we're going to see because we have another service offered by the provider that's known as Route 53, right? That is all about DNS management, right? Okay. Next thing is storage classes. Now, Provider is offering you so many different features in S3, right? And so accordingly, it has created the classes. Now, basically, these classes are created just to save upon the storage cost, basically, because not everything is available in every class, right? So by default, what happens? Now, different types of storage classes. One such class is that known as standard, Amazon S3 standard class. Now, this class is the default class. That is, if suppose you upload the object, by default, your object goes into standard class unless you specify something different. So standard class is default, and second thing is it's costly. As compared to any other class, it is costly, right? Why is it like that? Because if suppose you are using the standard class, so you can access your object n number of times, right? There is no limit. Basically, the storage cost depends on two parameters. One is the frequency of access. How frequently you are going to access your data in the S3. And second thing is the duration of storage. How long you're going to keep it, right? Higher the frequency, right? More number of times you're going to access your data, it is going to prove costly, right? And longer the duration, suppose you're going to preserve your data for longer duration, cost is going to be less. Per GB storage cost is going to be less, right? So in standard class, this is costly because you don't have any limit in terms of accessing your data. You can access it n number of times, right? But as such, you are getting all the features here, no restriction, right? You're getting durability, 11 nines of durability, 4 nines of availability, right? All such things are there, meaning if you wish to have all the features, so you can go for standard class, which is by default, it is there. But I suppose you feel that I don't need all these features, why do you pay that much? It's costly. So you can reduce the cost, right? By using other classes also. For example, other class, standard infrequent access, right? Meaning in this class, you are getting the same feature just like that of standard class, with only one exception. And this time you are going to access your data infrequently, right? And if you are going to access your data infrequently, right? So it's going to be somewhat cheaper, right? But rest of the features you are going to have it. So if you feel that your need of accessing the data is not going to be that much, you can go ahead. But then there is condition. So here actually in this class, whenever you're going to use this class, per GB month storage cost is going to be there. Per GB month storage cost. And then the standard class, right? Meaning, see, you can make out per GB month. Month means the duration, and GB here is the amount, right? So what amount of data per GB and the duration, longer the duration, it's going to be cheaper. So here actually the storage cost is going to be less than standard class. But then condition is what? That minimum object size should be 128K. Minimum storage duration should be 30 days, right? And whenever you are going to retrieve your data, so per GB retrieval cost is going to be there. Now, this is something not there in the standard class. In the standard class, you can access your data n number of times and up to any extent, right? So here, there actually lump sum amount is going to be charged for you. But here actually, right, condition is that if you want to avail this infrequent access, so you have to have the storage duration minimum 30 days. Minimum 30 days or more than that. If it is less than that, then this class is not applicable, right? And whenever you are going to access your data, so what amount of data you are going to retrieve per GB cost is going to be there. So obviously it is best suited for infrequently accessed data, where actually you are going to store the data for more than 30 days. And the nature of data, like backups or older data, right? This is best suited where you are going to access it very limitedly. Then other features are same. Other features are just like that of standard class. You have got real-time access, meaning high availability, right? Same low latency and high throughput performance. 11 nines of durability, 4 nines of availability, all such things are there, right? With only one exception, right? This time you can access your data infrequently, but then condition is that minimum 30 days storage should be there, and the minimum storage amount of data should be 128 KB. Then other class is reduced redundancy storage, RRS, as the name suggests here, right? Reduced redundancy means redundancy is going to be less, right? I told you that when you are going to upload your data, so see, cloud infra is redundant, but on the top of that, when your data is going to be stored, this is again stored redundantly, meaning multiple copies are getting created. Multiple copies are getting created, right? But if you are going for RRS, if you say that, oh, I don't need those many of copies or that much of redundancy, so why should I pay for it? Right? My data is not that crucial that I should go for this kind of redundancy. So you can opt for this class. Redundancy is going to be less. So cost is also going to be less. But then durability is going to be reduced, of course, right? As compared to other class wherein you are getting 11 nines of durability, and it is only 4 nines of durability, right? As compared to standard or standard infrequent access, right? So it is more appropriate for the kind of data which can easily be reproduced, meaning even if suppose some losses are there, so nature of data is it can be reproduced, such as image thumbnails. Next, other features are 4 nines of availability as it is over a given year. And though it is reduced redundancy, but if suppose you compare the storage with traditional storage, what you're doing on your local disk drive, even then it is 400 times better, right? That is what this documentation says, that if you are using RRS model to store your data, it provides you 400 times more availability than traditionally the typical disk drive storage what you use, right? 400 times more better even then, right? And ultimately, we have the Glacier, which is the lowest cost storage service. As the name suggests, Glacier meaning it is as good as saying cold storage kind of thing, right? Once you store it, your data is going to be preserved, not stored. Rather, it's preserved over the years, long-term storage, right? Wherein actually rarely you are going to access it. So here actually, the nature of data is you have data archiving, right? Online long-term backups, but more importantly, data required for compliance purposes. Right? You are maintaining that data only for compliance. Actually, you don't need it. Suppose the compliance rule says that this kind of data you have to maintain it at least for 10 years, right? This is a compliance. So you have to, right? Rarely you are going to access it. So in that case, Glacier is the best option, right? Wherein, but then condition is that if you're going for Glacier, so minimum 6 months storage duration should be there. Only then this class is going to be applicable, right? But then it's going to be the extremely low cost storage service designed for infrequently accessed data, right? Retrieval time is more, right? It is not this much now. Time they have improved upon. It is about 5 to 10 minutes nowadays, but delay is there, right? Waiting period is there. Whenever you are going to retrieve the data from the Glacier, some delay is going to be there. Earlier it was more, but now they have reduced the time. But yes, delay is there. Then other features are same, unlimited storage, any kind of data, any format, right? Most of the time we are using tape archives, GIF files, right? Long-term storage. Then redundancy is there. Your data is going to be stored onto multiple facilities, 11 nines of durability. But yes, one condition is there that Glacier, this class, you cannot specify directly, right? Rather, whenever you're going to upload your data, so you have to have it either in a standard class or reduced redundancy or standard infrequent access, and then you can transition your storage to Glacier using lifecycle management rules. So lifecycle management rules, these are kind of automation, wherein actually once you define the rules, so automatically as per the rules, your data is going to transition from one class to another. And the objective is to save upon the storage cost. As I told you that standard class is very costly, right? And if you feel that I don't need these features which are being offered, right? So you would always like to transition to other class. For that, we are configuring lifecycle management rules. The next thing, management rules. So these lifecycle rules can significantly reduce storage cost by automatically transitioning data from one storage class to another. Or you can even configure it that your data should get deleted automatically after a certain period of time, right? For example, now this is how the rules look like. Store data when you're going to store it for the first time. So it goes initially into the standard class. Now you're defining the rules. Then after 30 days, it should transition to the standard infrequent access because this is a condition. See, you store your data into standard class, and suppose it is there lying in the standard class for 30 days. You're not retrieving it. So condition for infrequent access is satisfied, and automatically your data is going to transition to this infrequent access. And what is what now? Right? Charges of infrequent access will be applicable now. That's how it is going to reduce upon the storage cost. Then after 90 days, it will transition to the Glacier. And after 3 years, it will be getting deleted. Now, this is just an example how your lifecycle rules look like, right? So once you set these rules, automatically as and when the conditions are fulfilled or conditions are satisfied, classes are going to be there. Your data is going to transition from one class to another automatically without any manual intervention. And you can also specify when this data should get deleted. Suppose your compliance says that you have to maintain it for 3 years at least. Fine. So after 3 years, it will be getting deleted automatically, right? Now, when you configure these lifecycle rules, you can attach it either to the bucket, right? If you attach these rules to the bucket, in that case, rules are applicable to all the objects in the bucket. Or if you want to attach these rules to a particular object, that again can be specified by a prefix. So both possibilities are there. And 1,000 lifecycle rules can be configured per bucket. All right. Everything has got a limit here also. But the rules has failed. All right. Then next part is again related to security, right? Encryption. In fact, encryption is related to confidentiality. Confidentiality. That is when you are going to store your data. So right from your location, right? This is the client side, and this is the cloud location wherein you have the storage servers, right? From your location, you are going to upload your data. So you can configure encryption. Encryption at client side, encryption during the transition when the data is flowing over the network, encryption when the data is getting stored on the server side. We call it as server side encryption, client side encryption, server side encryption, and encryption during the transition. Yes. So Amazon says that your sensitive data should be encrypted. Encryption means that your data format is going to be changed. It's not going to be in the readable format, right? So even if suppose somebody hacks your data, whether it is there in the storage or whether it is there in the transition, nothing can be made out, right? Even after hacking the data, nothing can be made out because it's all garbled, basically, right? That's the encryption. So now when you are going to encrypt your data in transition, we are using the SSL API endpoints. Same, just like you are using for a website. Nowadays, actually, when you access the website contents, it's all secure communication because at your end, you are using HTTPS, Hypertext Transfer Protocol secured. So this protocol ensures that whatever sessions, web sessions are established, they are all encrypted. And this is going to happen because your web servers or websites, they're enabled with SSL, Secure Socket Layer. This is a protocol, right? So once you enable this SSL, then you have to use from your browser HTTPS. Similarly, here in storage, this is web-based access. So once you enable SSL API point, so you are using HTTPS protocol to upload your data or download your data, right? So this is going to ensure that when data uploads or downloads are being made, they're all encrypted, right? We call it as data in transit encryption. At rest, meaning client side or server side. Client side encryption is there. S3 supports both client side encryption and server side encryption, right? To protect the data at rest. If you're using server side encryption, so what will happen when the data is uploaded? So before actually it is written here on the storage servers, it's going to be encrypted first and then it is saved on the disk. Vice versa, that is when you're going to retrieve the data, it is going to be decrypted, right? And then it is downloaded, right? So what I mean is that encryption or decryption process, it remains all transparent to the end user. It remains transparent. Client-side encryption. In client-side encryption, you as a client, you are responsible for encryption. And for that, you are going to manage this entire show, like from the encryption process, encryption keys, and whatever tools. Clients are going to manage it. So what I mean is that S3 supports all kind of encryption at all the levels. Whether you talk about client-side encryption, server-side encryption, or encryption during the transit, uploads and downloads. So this is basically to secure the confidentiality. That is, even if suppose data is, hacked, illegal access is made. If it is encrypted, nothing can be made out, right? That's the whole idea. Fine. Then other features, versioning, MFA delete, and cross-region replication. These are the three features which are offered by the provider to protect your data from accidental deletions and modifications, right? See, earlier we have discussed that when data is uploaded, so data is stored in a redundancy, right? But that redundancy is not for you. It's only for the provider. That is, if suppose something goes wrong in the cloud, right? Some failure happens, power failure, network failure, disk failure, device failure, whatsoever. So by maintaining the redundancy, provider is ensuring high availability and durability, right? But if suppose you as a user, you happen to make some accidental mistakes, you deleted your data, right? It's an accident deletion. Or you modify your data, you overwrite, and then you claim that, okay, this is something by mistake and I want my data to be back in place. So provider cannot help you that. But it offers you certain features which can protect your data from such accidents. So one such feature is versioning. Now by default, versioning is disabled by default, right? So once you enable it, suppose, so it is going to be enabled for the entire bucket, not for a particular object. But let me tell you that all these features, if you enable them, you have to configure them basically. They are not there by default. So they are chargeable basically. So in versioning, what happens actually? That once you enable it, now whenever you are going to make the upload or you are going to create a new object, every time a version is getting created. Whenever you are going to upload your data over the cloud, so your data is going to be stored as a separate version, right? It won't overwrite, right? File name is there. Every object has got a key, right? So key will remain same, but then every object has got a version ID. Version ID is going to be different, right? Normally what happens is suppose you don't have the versioning enabled. So if suppose I modify something in the object and you upload it, it's overwritten, right? Just like there is a doc file, right? If I modify something and save it, it's overwritten. And once that is overwritten, if I want to retrieve the original file back, this is not possible. Same thing applies over here. But once you enable the versioning, so anytime if you modify the file, right, or you make a new file, it is getting uploaded with a separate version ID, right? That is the advantage. But then you should know it that it is going to increase that's when its cost also. Because every time, suppose for a given file, you have 3 or 4 files created with a different version ID. So your storage is going to be multiplied, storage space, right? So it's a costly solution, but then it protects your data from deletions. If suppose by mistake you delete your file, so it's not going to be deleted permanently. A copy is going to be retained, and you can always retrieve it. Similarly, if you overwrite the file, so it's not overwritten. Rather, a separate version is getting created, and so if suppose you want to retrieve any version, that's possible, right? So that is a plus point, but it is going to be chargeable, right? By default, version is disabled as I told you, but if you're going to enable it, so you cannot disable it. You can only suspend it. And versioning is there at the bucket level, right? Not at object level. Then you have second feature which you can do the configuration, that is MFA delete. Same MFA what we discussed in IA, multi-factor authentication. So once you enable this MFA, so same thing, you have to have a virtual MFA device, right? Which is constantly generating the code. So whenever you make a delete request, suppose you try to delete an object, if MFA is configured, so you are going to be authenticated for it. meaning you're going to be prompted for a 6-digit code, just like an OTP. And only when your code is correct, your delete operation is going to be successful, otherwise not. Right? That's the whole idea. So this is another layer of protection. Right? Just hold on. Somebody's there outside. Just hold on. Yes. And another thing is that MFA delete this option can be enabled by only root user account. Right? As I told you initially that root account has got certain special privileges. Right? So one such privilege is this MFA delete. All right. Then next is cross-region application. Right? See, when you upload the data, the replication takes place. But that replication, which is happening by default, this is all within the region. 3-4 copies, whatever are getting created, they all remain in the same region. Of course, into different zones or different facilities, but within the region. But if you want to have the replication across the region, you can do it. You have to do the setup for it, right? So what are you going to do? Cross-region application. You have to specify what is the source region, what is the destination region, right? You have to specify the source bucket, right? You have to specify the target bucket. This you have to, pre-configure target bucket, right? Suppose I say my source bucket is there in the North Virginia region and my target bucket is there in Mumbai region, right? This you're going to define well in advance. So when you configure cross-region application between these two buckets, cross-region replication. So there are certain conditions which should be satisfied. And one of the important conditions is that both of these buckets should have versioning enabled. Right? Versioning should be enabled at both the ends. Right? In cross-region application, what happens? Whenever you upload the data into the source bucket, automatically it's going to be replicated into the target bucket, which is configured into another region automatically. Right? On the top of that, once your data is replicated, in future, if suppose you make any changes in data or metadata or ACL permissions, this is going to trigger this replication. Got it? See, for the first time when you upload the data, it's going to be replicated into the target bucket, which is configured. Fine. But now, if suppose you make any changes in the data of this object or metadata or ACL, that is access control list, permissions, this is going to trigger this replication. But if suppose you delete the object, delete is not going to be propagated. If you delete this object is going to be retained. And so you always have a chance to retrieve the data, right? So here actually when we are going to have the replication across the region, so it provides you regional level redundancy. That is, even if suppose regional failure happens, right? If by chance, if this region is not available to you, even then data is available into another region. That's the whole idea, right? So whenever you're going to do the setup for cross-region application, versioning has to be enabled. First of all, you have to specify the source bucket and target bucket. This is one thing. Second thing is you have to specify the versioning. And third thing is, see, when data is going to be written from here to here. So permissions are required. As I told you, by default, permissions are not there. Any resource or application, what you're running here in the cloud, they don't have any permission to interact. So permission needs to be granted, that is by way of role. So you're going to create a role which allows the source bucket to write the data over target bucket. Yes, is this clear? So these are the three things which needs to be configured for task region application. You have to define source bucket and the target bucket, right? In both the regions. And enable versioning, and you have to have the permission in the source bucket by way of role, right? And then you can verify it. So we'll see it practically. All these things needs to be seen as practical, right? Yes. Any questions into this? But this actually theory part is over, and we are going to see the lab part. If you have any questions right now from this lecture or any other lecture, have it.
No, sir.
No, sir.
All right. Fine then. Okay. We shall be meeting same time. If suppose if it is possible for you, we can make it earlier so that we can devote more time, right? If we can devote more time, I can wind up the lab part tomorrow. Okay, continuity I need. So can you join earlier?
Yes, sir.
What time?
Or like
Sir,
last time,
see,
6 to 8 would be good.
Okay. Make it 6 to 8 then. Okay. Connect at 6 o'clock tomorrow.
okay, sir.
Right. And we'll try to wind up as much as possible. Let us see. Be there at 6 tomorrow then. All right.
Okay. Thank you, sir.
Fine. All
Thank you,
right.
sir.
Okay.